Good day everyone. In our last video, we talked about the procedures in taking instrument variables to data. So in this video, we will be discussing panel data estimations in data. When we talk about panel data, we usually observe a person, a country over several time periods. So for this discussion, the data we'll be using is this. It, in- it includes 5 different countries from Asia: Indonesia, Malaysia, Philippines, Thailand, and Vietnam, which will be labeled as 1 to 5 respectively, with the variables of GDP, GDP per capita, import, export, population, and government consumption. So we got this data from the World Bank data catalog.
So the first step in doing panel data is we copy and paste this dataset into Stata. Don't forget to treat first row as variable. Next is to let Stata acknowledge it as panel data. The command for this action is xtset the country and the year. After we input this command, Stata will say that the data you have used is strongly balanced, and in this case our data is strongly balanced as you can see.
For the next step, we need to transform the variables into log form so that we can make it more efficient. And then we choose our dependent variable and our independent variables. For our dependent variable, we chose government consumption. And as for our independent variables, we chose population, gross domestic product, and GDP per capita.
And after choosing our dependent and independent variables, we start to regress. After regressing, as we can see, the R squared is 99% and the adjusted R squared is also big, which is 99%. So population, GDP, and GDP per capita explains 99% of government consumption of the 5 countries from the year 2000 to 2019, ceteris paribus.
Based on the adjusted R squared, there is no omitted variable bias because, as you can see, it is more than 10%, which is the rule of thumb. But for discussion purposes, we will assume that there is omitted variable bias and there could also be a heterogeneity problem. And as to how we address the issue of omitted variable bias and heterogeneity, we use fixed effect or the random effect by using the Hussman's test. Remember, if your adjusted R squared is lower than 10%, then use the Hussman's test so that you can distinguish if you are going to use random or fixed effect.
So now we will perform the fixed effect regression with the command for stata xtreg followed by the dependent variable which is government consumption followed by the independent variables which are population, gross domestic product, and GDP per capita. And then at the very last put comma FE. Based on the results, here, only gross domestic product is statistically significant at 1% significance level. After this, we input the command estimates store fixed so that Stata would save the values.
Next, we perform the random effects regression with the command for Stata xtreg dependent variable followed by the independent variable, comma, and then RE. Now, based on the results, again, gross domestic product is statistically significant at 1% significance level, and GDP per capita is statistically significant at 5% significance level. And like the fixed effect regression, we let data save our values with the command estimates store random.
And then after testing for fixed effect and the random effect, we now input the command Hausman fixed random so that we can determine which effect is best to use. So in order for us to analyze this, if the prob chi is less than 5%, then use the fixed effect. In this case, the prob chi here is 8%, meaning we use the random effect.
So now that we have tested for Hausman, we now proceed to test for serial correlation and heteroskedasticity, because panel data is likely to be affected by both of these. But if heteroskedasticity and serial correlation are not present in the panel data, then the final estimate will be the Hausman's test. In order to find out the heteroskedasticity and serial correlation are present, then we need to test for it.
So for heteroskedasticity, we use the iterated generalized least square or the IGLS regression. So the command for theta is xtgls depth var in depth vars IGLS panels heteroskedastic. After we get the values, we let theta again save the values with the command estimates store hetero. If ever you have questions about this and how to test for it, you can actually go to their website www.stata.com. Here you can get access to commands and how to test for heteroskedasticity and other more tutorials. And when you see the commands, you can easily just copy paste them into Stata. Don't worry, we attach a link to let you navigate directly to this tutorial.
So after storing the values into Stata, the next step should be inputting this command into Stata. XTGLS, government consumption, and then the independent variables, comma, IGLS. This is to fit the model without heteroskedasticity. Then right after, you go back to the link posted in the description to copy and paste the next command. So this is the command. Then the last step for testing is to input this command to Stata. Again, you can go back to the link in the description to copy and paste the next command. But the analysis for this test is together analyzed with autocorrelation.
For autocorrelation, we have Waldridge test in panel data. Before testing for serial, we have to download some packages for first for Stata to test for serial correlation. So the command is find it xt serial. This will direct you to a new window from Stata. We look for the program called NetSG3-2ST0039, or you can type in the command section NetSG 3-2 ST0039. Then you install it by clicking or commanding net install ST0039. After installing the package, we can now continue in testing for serial correlation by typing the command xtserial depth var in depth vars. Now, the analysis for this is a significant test statistic indicate the presence of serial correlation. From our result in the p-value, it is highly significant at 1% significance level.
Therefore, random or fixed effect will not be our final analysis because there is a problem for serial and hetero. It is said that if there is significance, serial correlation is present and heteroskedasticity. To address this issue, we will now use the population average model or generalized estimating equations XTGEE command in Stata. So the command will be XTGEE Y list X list, comma, core, open parenthesis, R space 1, close parenthesis, space robust. Therefore, this will be our final estimate.
So this is how we arrive for our estimation by using the population average model or the GEE. So thank you for watching and hope to learn something from our discussion today. See you in the next video.